Hello, and welcome to 3-2 Graphing Quadratic Functions Vertex form. This here is the basic vertex form equation. I'm going to explain what each of these variables do to the graph, starting with the k. The k affects the graph up or down. Basically meaning it'd be the y of your vertex in the parabola. Now I'll explain what the h means. The h affects the graph left and right. Basically meaning it is the x in a quadratic formula. Now knowing how the h and the k affect the graph, you would know that the h and the k would be the vertex of your quadratic equation. Lastly, I'll talk about the a. The a will determine if your graph is upside down or right side up. It also affects if it will be a vertical stretch or compression. We are now going to work on this sample problem together. We can start by finding the vertex. We see in this equation there is no a or k. That meaning the vertex will be 4, 0. If you're wondering why it's positive 4, in the vertex form equation it's a to the x minus h plus k. A minus and a minus make a plus, so it'd be plus 4. We can now plot this point at 4, 0. Now I'm going to explain what the axis of symmetry is. That is where that is a line that goes through your vertex. So if your vertex is at 4, 0, your line of symmetry goes right through the vertex. I'm now going to explain what the 1, 3, 5 rule is. So if we put some numbers in the graph, the 1, 3, 5 rule is every time your graph moves over 1 on the x-axis, it moves up by 1, then 3, then 5, then 7, and so on. So if it's 1 away, it'd be 3, 1, and this is also 1 away, and then it would be 4, like that. That is what your table would look like. Now we can start and graph some of these points. Then we'd have 5, 1. Now I'm going to show you a little trick. If you only have one side of your parabola, if you use the axis of symmetry and you reflect all your points over, that would give you your parabola. So there is your parabola. Now all we have to do is finish it off. Now we are going to start to understand what the roots, the x-intercept, and the y-intercept is. So we know that the axis of symmetry crosses at x equals y equals 4, so put that there. And now I'll explain what the roots are. The root and the x-intercept is the exact same thing. It's where the graph passes through the x-intercept. So in this graph, there is only one point where it passes through the x-intercept, and that would be the vertex. So we'd know the roots would be 4, 0, and the x-intercept would also be 4, 0 because it's the same thing. The y-intercept is where the graph passes on the y-axis. So on our graph, we don't know where it passes through the y-axis. This is where we can use a little trick. Using the 1, 3, 5 rule, we know that the next closest point is 2, 4 on our table. So if we went left one more, it'd be 1, and then our next number would be 5 in the 1, 3, 5 rule. So it'd be 1, 9, and then all we'd have to do is one more. So if it's 1, 9, it'd be 0, 16, because we move up by 7 when we go in order with the 1, 3, 5 rule. Now here's another example or a problem you can work through. So give it your best go, and if you can't figure it out, just play the video again and I will have it solved for you. And this is what your final product should look like. You see that the vertex is at -6, -3, and I figured that out using the vertex equation, and knowing that the k and the h give you the vertex. So that's how I got the vertex. The axis of symmetry is the line that crosses through the middle of the vertex, and that was at -6. And the roots are the x-intercepts. So in this problem, the x-intercepts or roots didn't land on a point, not an exact point, so I consider the roots not pretty. Not pretty meaning they are not a whole number. So you technically could figure out what the roots were, but since this is a video over learning how to graph and not learning how to find the roots or the x-intercepts, we didn't go over that. I'm now going to explain how I got the y-intercept, and I'm going to draw a table over in the top left to explain how I did so. So here's the table. We'll start with -4, 1, then -3. Fill out the y, or the x points first. So we'll use the 1, 3, 5 rule. So getting to -4, 1 was using the 3 already. So we know we're starting by going up by 5 if you just look at our original table. So if you go up 5 from 1, it'd be 6. So -3, 6. And then you'd go up by 7. So -2, 13. Then up by 9. So -2 or -1, 22. Then finally by 11. So you'd be at 0, 33. And that is how I got the y-intercept. So we're going to go into the final problem. I'll be right back. This is going to be our final example, and give it a try yourself, and then once you try working it out, come back to the video and I'll show you the final product. Be careful, look at the a in the graph, -2. Just know what that means. So this is what your graph should look like. The vertex is 2, 1. And now I'm going to get into something you might not have known. How to graph with a vertical stretch or compression. So when you have a vertical stretch like this one, first it's negative, so off of that you know it's going to be upside down, and the vertex is going to be a maximum, which means it's the highest point. So now, back to the 1, 3, 5 rule. When you're graphing a normal graph with an a of 1, it's 1, 3, 5. But when you're graphing something with an a that isn't 1, like say in this situation 2, you'd multiply the 1, 3, 5 by 2, so then it'd go up by 2, 6, 10, so on. And that is how I got my table. So in the middle of my table, it's 2, 1, and then to get to 3, -1, instead of using the 1 on the 1, 3, 5 rule, I had to multiply it by 2, so I'd get to -1, and then to get to 4, -7, I did 6, because 3 times 2 is 6. So that is how I graphed the parabola and got the table. Now, again, in this situation, the roots and the x-intercepts aren't pretty points, and we're not really getting into depth on that because that's not what this lesson is about. This is learning on how to graph it, like I explained earlier, so that's not something we need to worry about now. And to get the y-intercept, just look over at your table. It shows it. So when your x is at 0, your y is at -7. So your y-intercept would be 0, 7. So that concludes the video. You learned today how to graph quadratic functions using the vertex form. And I just want to say thank you for watching the video, and I hope you learned a little bit here today on how to graph. And just keep practicing, and you'll be able to get really well at it. So thank you.